An overview of ACI fabric configuration in the context of OpenShift installation on bare metal servers provided by iserver application. iserver is an open source command line application that, based on user input, can install OpenShift on bare metal servers, as well as check or configure data center network for servers connectivity. Check an overview video in the playlist for more information. The goal of this video update is to analyze the ACI fabric configuration mode workflow. One-time requirement is to create an ACI connector that contains the details required for REST API access to ACI controller. ACI configuration intent is defined in a fabric JSON file that contains controllers blue and servers with interfaces green parts. In this example, we have single APIC referred by connector name and a single server with two interfaces. The linkage between the controller and server's interfaces is the domain name, highlighted in red color. There is no difference between server's green part in the ACI check mode or configuration mode. In both cases, the green part provides exactly the same information as defined during the installation, except for node and port attributes. The blue controller part will contain some extra definitions triggering the ACI configuration mode. This example shows the smallest possible controller definition triggering ACI configuration mode, where tenant, VRF, and L3 out values are defined. Moreover, these objects are read-only, meaning they have to be already existing in ACI. All other policies and objects required for OpenShift cluster connectivity to ACI fabric will be created based on defaults or user inputs. The name of these objects will be based on moname attribute value or can be also defined by user. You can see in the title of this slide the reference to ACI configuration mode with BDEPG. This is due to the fact that ACI needs to be configured differently in case of BGP between OpenShift cluster and ACI, and in case of no BGP between cluster and ACI. BD/EPG configuration mode is where BGP is not enabled on ACI fabric and obviously not enabled on OpenShift cluster neither. You do not have to rely on defaults value though. All policies and configs details can be defined per controller in fabric JSON. Here we see the default port channel parameters that can be user-defined. Check the GitHub documentation for data model explanation, where the definition of all objects is explained, including defaults and supported and accepted user-defined values. You will also find in GitHub documentation the screenshots from APQI like this, where it is explained how the object properties from input data model make their way to ACI object model as well as APQI. These are all the objects, policies, and configurations created by iserver application based on fabric JSON input file, using defaults and generated names to make it easier to define the input values. You can always define your own names and object properties in the input fabric JSON file. The light green objects L3 out and VRF are the ones referred to by name in controller part of the definition that have to pre-exist. iserver runs fabric configuration mode in patch logic, so if the object, config, or policy already exists, it is only checked if it matches configuration intent. This is what we see here as an example output to keep the output smaller. Refer to GitHub for documentation of full outputs that show what happens when objects are created. Keep in mind that the fabric JSON definition prepared for configuration mode can be also used for check mode, simply saying in such case checks are more complete. So what we see here on this output? VLAN pool is created, and when I say created, I say it for simplicity. It really means patched. With a VLAN value in the pool, then a physical domain associated with VLAN pool, L2 domain is not needed in this mode, attachable access entity profile created, and associated with physical domain. Then we have backup policies being created with policy group. Policy group is configured on the target interfaces. Then bridge domain, application profile, and EPG with static ports is defined. These are all the configurations required to connect servers' interfaces into the ACI fabric. In case of BGP section, is defined in fabric JSON input file. So-called BGP L3 out mode of ACI configuration is triggered. That will have small yet important differences from the previously explained workflow. We will have L3 domain created. There is no bridge domain EPG created, but dedicated L3 out is created for BGP. Here we see in the graphical way the configuration changes that are created during the workflow. Again, refer to GitHub for more details. As you have seen, with minimum prerequisites, minimum pre-configuration of ACI fabric, you can very easily and intuitively abstract quite complex ACI configurations and trigger them with just a single command, leading to successful OpenShift installations without the risk of running into any problems due to network and cluster configuration mismatch.